Fantastic. Hi, everyone. So my name is Martin Redhead. I work for AWS as a senior enterprise solution architect, coming up to my third anniversary. And my pleasure to present to you the announcements for the month. So November, as you can imagine, is packed full of announcements because we're about to launch reInvent. And so everybody in all the service teams saves up all of their announcements just for this month. So when we were curating this, we had about 120 announcements. I'm not going to give you 120 announcements. We've cut it down to the top 15 or 20 I thought you might find interesting. So if you're interested in any other topics that we don't cover here and you want to know about it, see myself or Mark, and we can talk to you about it or put you in touch with the right announcements. So we'll kick it straight off with everybody's favourite, compute. So in compute, we are now supporting Windows Server 2025 images on Amazon EC2, right? So obviously Windows servers are hosted on Amazon quite a lot. We have a lot of customers. In fact, fun fact, we run more Microsoft workloads on Amazon than Microsoft do on their own cloud. So it was natural that we would support Windows Server 2025 images for EC2, and they're the basic areas for it. We also support Nitro-based instances, which is why a lot of people come to us for running compute, right? Because Nitro instances are a shitload cheaper to run on us. So Nitro, for those who don't know, is an Amazon proprietary silicon that runs significantly low power, which means that we can run it cheaper than AMD or Intel chipsets for the same workload. We now support Apple macOS, and that includes the latest iteration of what am I on now? Sonoma? No, it's the next one up. Whatever was just released. We now support Apple macOS as a supported EC2 instance in the image builder. So if you've got workloads like macOS apps that you're building that you want to test in the cloud, then you can support that on an EC2 image builder. For anybody else who doesn't know, we also have a thing called AWS Device Farm, and Device Farm is for anybody who's doing a mobile application that is aimed at multiple platforms. Maybe it's Apple, maybe it's Android, maybe it's a Motorola. Who knows? Maybe you've still got a flip phone. Who knows? Mark, they're coming back. We will stand up all of those as a virtual appliance for you, and you can run all your tests against those in the cloud instead of having to have physical devices all the time. So you can just spin them up and spin them down as virtual device platforms. Artificial intelligence, it wouldn't be an announcement unless we touched a bit on AI. At least we started to drop the word gen a bit, so it's just AI now. We're not generating all of it. But this is an exciting one. Amazon Bedrock Prompt Management is now available in GA. So if you've been playing around with Gen AI over the last year or so, and most people have, you'll realize that getting the best out of a model is about how well your prompt goes into the model, right? And so there's become this art form or engineering form that is called prompt engineering. And so now we've brought that into a prompt management area, which is incorporated into Bedrock, and Bedrock Studio is announced, right? Yeah, okay, I can talk about Bedrock Studio, right? So Bedrock Studio is, yeah. It is now. Bedrock Studio will be one of the features of our reInvent announcements coming up, right? So there's a lot of features being in preview at the moment for Bedrock and Bedrock Studio, which is going to be our fully featured AI ML environment. And prompt management is one of those things. So you were starting to see like really sophisticated prompts, which are maybe a couple of hundred lines long. So you can almost think like your programming now is in the actual prompt that you feed into the LLM. So you now need a way to manage those prompts. So that's also not the only technique for doing AI. There are other different ways you can do it, like using fine-tuning and agents and agentification. So prompt management is one of the techniques, and we do have one of those now launched. Claude, obviously we're keeping up. We're the tier 1 Anthropic Claude hoster anywhere in the world, and we've expanded our relationship with Anthropic this year as well. So Claude 3.5 Haiku model is now available in Amazon Bedrock, and just not to be done, we've also done 3.5 Sonnet is now available as well. Fun fact, I saw an announcement this week. I think I can say this, yeah. Copilot is, in Microsoft land, is now able to select Claude and Claude Sonnet as their back-end LLM. And just for fun, that's hosted on us. Hey! So interesting kind of development there in our friendly competition with our friends in blue. In developer tools, this one was exciting to me. The Lambda console now features a new code editor based on Code OSS, which is basically Visual Studio Code, the open source version of that, right? So we finally got around to putting a decent code editor in there for Lambda, and it's all based on the stuff that most people are using anyway, which is the Visual Studio Code base. So that's kind of cool. We've finally got some really rich code editors built in so that you can move ahead with that. You can do, so Amazon Q Developer, which is of course our AI assistant that sits alongside you as you're developing, supports inline chat to streamline the developer experience. So you can actually have a Q chat window open while you've got your Visual Studio open. And in fact, there is a plugin for Visual Studio, and you can just say, hey, you know, how would I write a Lambda function that talks to a stateful REST API in DynamoDB or something like that? And it'll go, oh, here's a piece of sample code for you, and write it for you. So really cool, and then you can ask follow-up questions. So it's an inline chat utility that's built into Q for developers going forward. And I think Alan will probably cover some of that a bit later. We also, this is interesting, I didn't realize that we'd done this until I was looking through the announcements. Amazon Q Developer plugins for Datadog and Wiz now generally available. So we're now starting to see Q Developer extend into third-party and ISV products as well. So where you can start to use Amazon Q not only for developing Amazon service code and general development code, but you can actually start to use it for configuration of things like Datadog and Wiz services. If you don't know what Datadog and Wiz services are, that's okay. Network content and delivery, I cut this down quite a lot, but I did like this. This was an interesting one. Amazon CloudFront no longer charges for requests blocked by AWS WAF. So that's a fairly significant one that we've brought in. So that should drop, if you are using AWS WAF, that should drop your bill considerably. Because obviously the job of WAF is to stop a lot of stuff. Right, so we've decided not to charge you for doing its thing, all right, which I thought was, hey, kind of cool. And it goes along with the standard Amazon ethos, so if we can make it cheaper, we will. Security, identity, and compliance, a couple of interesting ones that came through here, and this is one I picked up on. Resource control policies. So if you're familiar with the concept of service control policies, which are control policies that you can organize in an enterprise to say, you're allowed to use SageMaker, but only in these regions, and only if you have these roles. That's a service control policy. You can now do a resource control policy. So you can do resource control policies around any Amazon resource in the platform at the moment. They apply to STS, the key management, SQS, and AWS Secrets Manager, right? So yeah, so very similar to service control policies. This is an area that will expand as we go forward. This was an interesting one because I've had clients that have come to me with this problem. AWS organizations member accounts can now regain access to accidentally locked Amazon S3 buckets, right? So this was usually a painful process to go through. You'd have to raise a ticket, depending on the severity of the impact. It might be a Sev 3, Sev 2 ticket. And then you'd have to get one of our support engineers online to start working through this process, right? Quite deliberate because you don't want it to be unlocked if you meant it to be locked. So you want to make sure that we've got the right people unlocking it, but we've now sort of effectively worked out a process for unlocking those things. So if you need to know more on that, just let us know. You can also centrally manage root access in AWS Identity and Access Management, which is kind of cool these days, right? So identity and access management is becoming richer and more relied upon across a lot of our services. So being able to centrally manage those, and especially in root credential accounts, really helpful. Also, if you're using a root credential in your account, don't. Management and governance. So Control Tower launches configurable managed controls implemented using resource control policy. So we have resource control policies now implemented. So that's now being leveraged by the Control Tower setup process, so that all of your governance and of your landing zone can now actually be controlled by that. So it's just a natural extension of Control Tower. So Control Tower allows you to control your organizations, what accounts go into your organization, what service control policies they have. We've now extended that to the new feature, which is the resource control policies. So there's some the services that we're using there: S3, STS, KMS, SQS, and Secrets Manager. FinOps, or Cloud Financial Management. Cost allocation tags on inference profiles. So this is an interesting one. So when you get into the weird and wacky world of ML ops, you start to work out, like, there's different ways of tagging who's using what and who's using up all the tokens and who's getting what, what models spun up. So you can actually now tag an inference profile, and so you can actually have that cost allocated to a specific user or a specific enterprise group as well. And that's something that we hadn't initially thought of, but we have now introduced tagging on inference profiles. This one's cool. I don't have too much more on, so I'll keep going. EventBridge announces up to 94% improvement in end-to-end latency for event buses. Now, that sounds like a big claim, but it is actually a big deal, because if you've ever used EventBridge or EventBridge event buses, they become a really handy way of connecting services together in an event chain, right? So if you're trying to do a data pipeline or you're trying to do some sort of automation sequence, then the latency of the event notifying the next event to kick off and get things going, especially when you roll that out at scale, becomes important, right? So this, while it seems like just a simple performance thing, they've brought it down from 2235 milliseconds at P99, and in January 23 just to 129 milliseconds at P99 in August 2024. So it's a significant reduction in time and major improvement in performance. So event bridges are literally close to real time. And that's it, I think. That's all I had. There was 100, these are the slides that you missed out on.
Console design.
Yeah. And that's it for me. So any questions? No? All right.
Thank you, Mark.
No worries.
Keep us updated.
Cool. Hello, everyone. I'm Ben. I am the principal security engineer at Bugcrowd currently. My background is mixed. I used to be in infrastructure and MSP space, and I'm in the security space now. But this isn't about me, thankfully, because that would be really boring. Today I'm here to talk about how I explore secure code review using LLMs, and specifically ultimately using Amazon Bedrock. I would like to just be very clear too, unfortunately I won't be able to provide a demo today. I'm changing employers, and I'm just clarifying some stuff to make sure I still own the IP for this, because it is within my own team. I just want to make sure that I don't cause any problems for anyone. So I promise there is a little teaser at the end. I will be releasing this stuff. I've just got to get past the legal side of it. But like all presentations, this starts with a story, a very deep personal story. It's the sad tale of Froyolo. So it's Lord of the Rings, but imagine instead of the whole fellowship, the author decided for whatever reason that he was just going to, it was too hard to involve others. So instead he just sent Frodo off into Mordor on his own, right? With predictable results. Sauron wins, Middle-earth's doomed, Frodo's dead, Gollum never got his taters. Cool. I'm starting with this story because I went on this adventure, but more on that later. So way back in 2023, I had an idea. Secure code reviews were becoming a massive drag. So to be clear, this isn't traditional code reviews. Some of you may work as software engineers, etc. It's specifically in the secure code space. So when a team would want to make a really big change to a product in a previous company of mine, we would have to review the impact of this and do different inspections. So that might be looking at new components, things like third-party services or third-party dependencies that were introduced that hadn't previously been evaluated, changes to input, changes to auth-in, auth-set, et cetera. The list goes on. Those reviews were super time-consuming. So everyone was talking about these LLM things, and everyone told me that they could apparently code and understand how to code. And I figured, if they understand how to code, they understand how to review code theoretically. Most of what I looked at was like the same code 99% of the time, right? So I had my galaxy brain moment. LLMs could do my code review. And I spun up OpenAI. All was well, harmony in the universe, except there was one small problem. Like, it sucked. It was really bad. So I'm not showing outputs or anything because it is actually embarrassing how bad the results were. We had hallucinations and falsehoods. For example, the LLM would be like, bro, I promise you this project's written in Ruby, but the reality is it was Java. It would also mix up ideas about the kinds of vulnerabilities. For example, again, same Java code base. It would turn around and point out Python decorator issues and things like that. And I'm like, okay, this is not good. And there's a lot of reasons for this, right? So, LLMs don't have real reasoning. We kind of like to pretend they do, but the reality is they're a statistical model. So it could only really regurgitate stuff back in 2023. It also had no context. The context window for LLMs back in the day was very small. I say back in the day, it was only a year ago, but it seems like back in the day, right? LLMs are really small, so it couldn't look at the code in a broad sense and understand it. So I gave up, because that's what all engineers do. Really what happened is that I didn't have any more time to spend on this, and more important things came up. So time passed, kept doing the same things, changed jobs, still had the same problems, still kept hearing about these LLM things. I did that again. I don't know why I did it again, but I did it again. I thought maybe LLMs could do my code review. It's part 2, Electric Boogaloo. I spun up OpenAI. It still sucked. Yay. It was a little bit less this time, though. So we had some improvements. There was less falsehoods in the sense that it wasn't hallucinating. So the problem with hallucination, right, is that it can wrap like truth and falsehood into one thing, so you can't actually tell the difference between truth and falsehood. There were less hallucination. It was just like wrong. It's a lot easier to work out if something's wrong than if it's lying to you. So that was a bit easy to deal with. Reasoning had improved. So at a certain point, OpenAI added the ability for the LLM to act like a code interpreter. So I could use that to kind of spit more useful stuff out. But there was still a problem with context windows, right? Like, these LLMs are really small. They're kind of like smooth brain. They don't have a lot of space in there. Speaking of context, RAG exists, which is a whole change. And I'll talk a little bit about RAG in a bit because it's a thing. But I'm a millennial, and there's a glimmer of hope here, so I persisted. I fixed my skill issues, had a little training montage. First up, I added RAG, or Retrieval Augmented Generation. RAG is the ability to augment an LLM with a corpus of data and essentially allow it to reference things when it's not sure if it wants to answer a question. So that's pretty useful to have. Like, I can basically say, here's my code base, because in the past, I would actually just be sending it like code at a time, like file at a time, which is awful. Instead, I can give it a place, usually a vector database, to go, hey, here's my code, let's reference that code. Cool, really useful. I stopped sucking at prompting because prompt engineering started existing. I don't know if it really is, we heard art. It is really an art form more than a science form. Some LLMs just change their minds. But the main concept I started using was the concept of few-shot prompting. So a few-shot prompt is essentially, I give an LLM examples of the kinds of answers that I want to hear from it, and it will then sort of try to make sure that it's relevant to that, and it helps prod things. The second aspect was I did some experimentation using a concept called self-consistency. It's really just a fancy way of saying I wrote a whole bunch of prompts that should theoretically have the same answer, and then used the one that was most consistent at giving me the correct answer. So the real consistent part is me, not so much the LLM. But yeah, the idea is that you give it the same inputs, and therefore you get the same outputs. So I would have a known quantity of data. I'd say I've got a code base. I need to make sure I'm getting the same results. It still sucked. It was a little bit less sucky, but it still sucked. But I did have a realization, and this is where we go back to the beginning. I sent Froyolo on his way into Mordor, and predictable results happened, right? I'd been fro-yoling. I hate that word. I don't know why I even made it up. I sent my little LLM into the fires of Mount Doom without a slice of elfish bread. It was doomed, right? Because there are two approaches to LLMs. One is the fro-yolo or like mega prompt approach, which is what I'd been using. Essentially, you have a single prompt that says, hey, bro, do this thing and give me back information. And it really doesn't do a very good job of that because it's way too much to ask of it. And the second approach is the fellowship, or the agentic approach, or the agentified, I don't know what word to use. Anyway, it's using a bunch of little agents that do specific things, and they feed each other information to help get the right results. And I went really hard on agents. Like, I created agents that parsed out dependencies because I was too lazy to write Python to parse out log files. I then took those parse results and threw them at third-party tools and then got back results, and then agents looked at those results. I had agents that read documentation, which, by the way, the smartest thing you can do is have an agent that looks at the documentation of the thing you're trying to evaluate, because then the other agents can ask it questions. It became really chaotic because it was like little people living in this virtual machine that was absolutely destroying my AWS bill. Anyways, we'll go on to builds in a second because there's another build that's about to come up. Anyways, I had agents that also understood the language they were parsing and tried to highlight common misconfigurations and footguns, things like, I'm in Ruby and I don't know how to use Ruby on Rails, like cause problems. I also had agents that would try to take all this and come up with cogent risks. And it was better. It was much better. But then I got my OpenAI bill. That hurt. I've never spent $1,000 on a new product I was trialing before, but I forgot to turn on billing limits in OpenAI, and that hurt because I was running the same code base many times a month. And that's when Bedrock came in. Yay, Amazon product plug. No, kidding, of course. It was actually great. It was cheaper, which was huge because I could, stop spending money on my side product that my, company would eventually try to claim as their own. But it also, most importantly, supported multiple model ecosystems. So I found in some situations, GPT was better at things, and a lot of situations, Claude is better. In general, in this task, Claude appears to be the best output. So most of my agents use Claude. But the idea was that I can use the ones that perform the best and sort of evaluate that and maintain that. And the best thing is structured outputs. I don't know if anyone's had the idea of ever used structured outputs before, but oh my, in the past, models would kind of forget that they had to output things in certain ways. So you'd ask it for JSON and you'd get back garbage. And it would just be random, like you wouldn't know that it was gonna happen. So like one day you'd be like, oh, why is my review, oh yeah, because it's giving me back Markdown for some reason, I didn't ask for it. Structured outputs can say, hey, it's the schema, make sure it's in that output, and it does. And most of the time it works. Yay, it works. But I'm really bad at writing Python. I'm not going to lie to you. I forgot more Python than I'll ever remember because I've been at places that have absolved me of the sin of using Python and switched me to using something like Go. But it was also spaghetti, and like half of it was written in Bash. And spaghetti is not something that you can use in production. So I panicked a little, had a minor existential crisis. I was like, why am I even doing this? Why would I even think this was a good idea? The usual sort of things. I refactored it, yay! The whole thing is now written in Golang because portability is way better. You're single binary, anyone can run it. Hopefully I'll be able to get it out to people. I promise I'm trying to. There are clear abstractions, so I can add multiple different model types, provide new vector stores, nerd stuff. There is local support. So I primarily use Bedrock, it's great, but it is also important to have things like local LLMs like Olama, as well as local vector DBs, because a lot of people don't want to send their data to a third-party service. Completely understand that. I'm sure Pinecone is mining the hell out of the free data you send them. But yeah, so that's the sort of thing. So what's next? At this point, I was like, cool, I want to show everyone a demo and show everyone how great it works. Unfortunately, I can't do that. So my presentation is cut a little bit short here. But I promise you, I am going to be open sourcing this. I may need to work that out, but I'm going to try to be open sourcing this. So hit me up on LinkedIn after this if you want to, get connected. I will announce it on there. I'm not sure. Obviously, I could pop it in the Slack channel and stuff like that as well. The idea is ultimately this will spread out a little bit wider than just secure code review. I'm ideally trying to make it into a sort of developer toolkit that can be used to enable code reviews at different levels. It was built with security in mind first, but it's flexible. The idea is I've created a flexible framework that can be used to build code review agents and sort of integrate your code directly into them. That's the stuff for now. Thank you. I apologize, it's woefully short. I'm surprised it even made it to like 13 minutes, to be honest. It's pretty good. Because there's no demo. But if there are any questions, please feel free to ask. Yes?
Can you, I know only the simplest thing about RAG.
Yeah.
I don't know how it works in amongst Amazon or almost anything. Can you just give us a little outline of how you know, what's the architecture of that? What sort of stuff are you putting in a RAG data set and how do you link that into your LLM?
So a RAG data set can be just about anything. The most common use case you'll see for it is documentation, PDFs, websites, and things like that. In my case, it's the entire code base. I'm loading that in. Usually it takes the format of a vector DB, so it creates relationships between entities within like a chain of entities and links them all together and does some statistical analysis so that when the LLM encounters a particular word, phrase, etc., it can follow that logical path. And that's really the main interaction point. So the LLM will basically have a query system back and forth. It depends how it's set up because you may have one where it's like the embedding model does it versus the overall LLM. But there's different ones where it'll basically use that as a search space for potential things to find. In the case of AWS, I could be wrong because I haven't actually looked deeply into the RAG side of AWS. I've primarily been using a piece of software called Pinecone and Redis because Redis also supports it. Obviously, depending on Elasticace's support level, you could potentially use Redis as a RAG. It has to support certain instructions though, so I'm not 100% sure. I know that RDS has some components for vectorization and things like that. Postgres has some wrappers you can use for vectorization, but theoretically you can use any database that has some form of vectorization functionality. And I'm sure people will be working on wrappers for things like DynamoDB and stuff like that as well. So, but yeah, what it stores is a structural representation of the text that the LLM can refer to.
Thank you.
No worries. Anyone else? Yeah.
How did you orchestrate your agents and how did you manage them?
Yeah. So the first version was using LangChain in Python. They have like an agent orchestration component. The agents are really just a set of particular prompts, and I have a bunch of like nice promises to await for the responses for them. The current iteration of them, I've written a custom sort of orchestration pipeline, which is essentially like almost like an event style architecture where an agent calls the response, gets back, and that's all happening over NATs in Golang. And so it uses like a plugin architecture to basically have an independent thread. Golang makes threading really easy, so all of my agents sort of sit in a thread and get polled. And that agent is really just waiting for a response from a third-party LLM service at the end of the day.
And do you make a specific agent for your specific use case, or can you make multiple?
So the idea of agents, you can either do what's called an individual agent approach. So you have agents that have specific things and that they just do that thing and then they return the output. Or you can have agents that interact with each other. So you can have like a multi-agent. So in some instances, I have agents that are standalone agents that just do a request, get a response. You know, I'm going to go do this query, get it back, return that data, make it available. And the way I make that data available for the LLMs is using either Redis or Pinecone again. So there's the RAG component there. Because you can set like a key space for a particular run. So I can say like, make this data available for this run. And then other instances, I have agents that actually talk to each other. So there's like the documentation agent, and then other agents can ask the documentation agent questions, which is a really bizarre concept, but it's like, it's virtual people in a way. It's almost like having a room full of experts. So one agent can go, hey, Mr. Documentation Agent, I need to know about this thing in this language or this thing in this product. Can you tell me how this is? And the documentation agent will go, here's the information I have, and return it in a structured format. And then the LLM will take that and go, cool, now I can answer my question. So in a way, that documentation agent kind of becomes a RAG as well. So yeah.
How long have you been working on it?
Far too long. No, so the Golang version of this started nearly at the beginning of this year. And because the space changes so quickly, I've had to change it constantly, which is probably the most frustrating thing. But we are starting to get to a more stagnant point where things aren't changing as quickly, which is great. But yeah, I've sort of settled on particular sets of models. I've settled on my structure. And the good thing about my structure is it's properly composable, so I can like change plugins and stuff rather than having to change the whole code base. That was kind of my biggest frustration with my Python spaghetti originally, was that every time something changed, I had to like rewrite the entire thing, whereas now I just rewrite a single plugin, which is really good. So yeah, it's been a couple of years of hitting my head against the wall, but that's how much I dislike secure code review, I think, in a lot of ways, is what that answers. I think it's a really useful tool and something that we should do, but it's most of what it is quite formulaic. You're going to do the same thing over and over again, and that's the best place to have smart sort of automation or enhancement.
That sounds pretty good.
Have you tried the OpenAI 01? If you have, is it any good for anything?
I have tried O1. It's still more. It's really expensive. The API calls are the killer. So in terms of performance, I found it quite slow, and I think a lot of us who are doing sort of similar things have the view that the reason it's really slow is because it's actually also an agent-based LLM architecture under the hood. So it's like agents talking to each other. So sometimes when you ask it really complex things, it just kind of hangs and takes a while. Its performance is comparable, I would say. I just find the Anthropic models much more responsive and quicker. Once you sort of get through how asinine they are, that's probably my biggest thing I've run into, is because the LLMs have sort of been designed to be very milquetoast and very like friendly to people. It's actually really hard unless you've got like an instruct model and you're building your own custom embeddings and things like that and pushing it to behave certain ways. And so using commercial off-the-shelf LLMs has been frustrating, to say the least. That's probably been the biggest barrier.
Thanks for the presentation. I just wonder if you have any particular list of problems that you would like to see highlighted after the review. And just to continue that, did you use it for analyzing open source? Like if you can see any patterns there?
Yeah, so the majority of the things that I was using to sort of work out whether it was working were open source projects, because I mean, it's the most unlimited source of potential mistakes that people can make, right? And that's all the programming in the world. The kinds of things I'm looking for varies heavily dependent. So I've used it in two main ways. One way, I'm got an open source product that the company wants to introduce, which is becoming more and more common at tech companies, right? People will go, I want to bring this open source product in and I want to use it as if it's a commercial product. So I will use it to then evaluate the entire code base as if it's a single thing and identify things like, does it have an issue with SQL injection? Does it have an issue that's presented via the framework? Like, for example, has it got Ruby on Rails? Cool, it's built on Ruby on Rails. The version of Ruby it's using is retired. The version of Rails it's using is no longer supported, and it's locked at that version. Or the really common one I see is that it's using Angular, which is not even supported anymore. Things like that. Angular JS, that is, because there's two of them now. Things like that's really important. Supply chain risks. So, for example, I've got third-party dependencies in the project. What do those third-party dependencies do, and how do they introduce risk? Bad code hygiene, maintainability issues. So has this project been modified in a long while? And some of that stuff I don't need LLMs to get, but it's sort of bringing that all in to give me a massive overview. And the kind of output is, I'd love to show it, but it's essentially a markdown report that I get. So there's a GitHub version that's sort of done via a PR bot. So you can run it as sort of a GitHub action approach or GitLab or whatever. It pops up when you do a new change. So I'm a developer, I've just added something. It goes, cool, what's this change relative to your own code base? What does it introduce? What risk does it introduce? And then there's also a standalone run mode where you get back a markdown printout, which is a total report. It gives you the language, the framework, the dependencies, how often it's maintained, whether they've got commit signing. It's a huge list of things. So yeah, it's a lot of data. The other thing that I've built into it is an output template controller, so you can actually specify the kinds of data you want to get back as well. So there's a set of macros that you can put inside like a formatting configuration file, and if you exclude macros, it won't run that part of the tool as well, so it speeds up time. So in the case of like PR reviews, it will, basically the control is built off how large the PR is. If it's a single file, it's only going to run minor stuff. If it's a larger change across multiple files, it's going to enable more modules and things like that.
What have you found that it does better versus more like static analysis tools and stuff like that?
Yeah, so static analysis always has a limitation of being based off a set of regex. And a well-maintained set of regex performs sort of equivalent to it. But that's kind of the problem, that most companies don't have the resources to build up a library of good semgrep rules or SonarQube and stuff like that. So what I've found is it's much more adaptable to situations where you have far less knowledge of the thing you're looking at in advance. Because I've spent a lot of time, and part of why I dislike secure code review so much is I spend so much time writing semgrep rules. And that's great when you write a semgrep rule and it fits the behaviors you expect and it has a control for that. But then over time, the code base changes, people change patterns, so you've got to maintain those semgrep rules. And I think having both is kind of the nirvana state. You kind of have like your no-nos, like for example, you have to have authentication on all externally facing endpoints, and maybe we should shift that to somewhere where the average engineer can't turn it off. It's probably a good thing. But then like, oh, this person's made this change which doesn't fit our formatting standards, right? And now semgrep, to be fair, has got a new AI thing which lets you ingest their code base. And at the end of the day, if that had have existed when I started this, I probably wouldn't have started this. I probably would have used that. But now this is so far down the path that it does more than that. And I'm like, cool, I'm happy with that. But yeah, to answer your question, this is much better in unknown situations when I don't know what the code base looks like, or it's a deviation from the norm, which is frequently what we want to look for in security, is changes from normality, because we know normal, we don't know unknown, unknown's scary. Cool. Sweet.
Any more questions, people?
I'm happy to push for more questions because Beats is meant to be here in 10 minutes.
Oh, good. You got 10 minutes of questions. Hit me.
And
It can be random too.
I got a tech support question actually.
Oh no.
It's an LLM question.
Oh no. Oh no. Yeah, sure.
So I've started my own journey, so
Oh,
probably all that.
don't make the Froyolo approach.
Nah.
Don't do it, agents.
And granted, like I'm a day in, so there we go. I'm trying to summarize a payload,
Yep.
and I need the output to only ever be 100 characters.
You need an instruct model.
Yeah.
For starters. So if you use any of the conversational models, that all goes out the window. I would suggest making sure you put that in the system prompt, because that can't be overridden. So depending on what model it is, it'll have a different format. Make sure you're using the prompt format. So if, like OpenAI has its own set of escapes, and then Claude has its own, and all the other ones do. Structured outputs can help. I don't know how well they work in terms of constraining how big the payload response is. So what you could do is, this is awful. Yeah, so I think like using the system prompt and then having something to check the result, right? So it may sound kind of weird, but you could take the last complete output of the token. What output are you looking for? Just a string, right? So you could take the last X component of a string and go to another smaller model and just go, does this look like a complete sentence? Does this look like a complete output? So if it cuts off, because it's like, oh, I gave you 100 words, I can't go any further, you kind of know. So you check the length. If it's over 100, cool. Yeah, just maybe you need to tweak your prompt. But my suggestion is you go down the path of the path of self-discovery and work out how to reinforce it. Luckily, I haven't actually had to constrain the length of any responses. The only time that is useful is when you want to restrict how much money you want to spend, because tokens cost money, right? That's primarily input, though output costs as well, but yeah. So unfortunately, there's no one-to-one way to do that, but those are a couple of things you could do.
I might have this a little bit wrong, but you're actually putting all the code you're wanting to review in a RAG data set,
Yep.
vector data set.
Yep.
But then you're still using prompts to try and
To gain specific bits of
elements what
information.
you want.
Yeah, yeah. The agent. So when we talk about agents, right, an agent is really just, depending on who you speak to, people will blow it up to more than what it is. But it's just a really narrow prompt ultimately, right?
Yeah.
Like you're prompting it to do something particular. So yes, there's still a prompt. There's still prompts involved. There's still system prompts involved. And then but the query is, given the data set you have, et cetera, can you answer these questions? Because that sort of changes the perspective you take. So you can have more conversational approaches, you can have more instructive approaches. So I've got mostly instructive models, and I've instructed them to sort of automatically go do a thing and give me back a response. Sort of similar to AutoGPT. I don't know if anyone's used that before. That was a framework release that essentially allowed you to give GPTs a set of tools and a task, and then you could kind of just press play and it would just try to like work its way to completing that task. And then that's what prompted the whole Skynet fear thing that everyone was afraid of, because like people would go do, I'm going to go AutoGPT earn money. Like that was the task they gave it, and it was like doing things like trying to short stocks and stuff, and like all sorts of weird stuff that nothing, it's not going to work in the short term most of the time. So it's sort of semi like the AutoGPT approach, with a very constrained set of tasks and a very constrained set of tools.
Second little part, your RAG data set is a very uniform thing.
Yeah.
That's well constrained. If you've got a RAG data set that's actually quite diverse and is a mix of human written documents, information signals, something that you might have actually needed to encode, do some embeddings for. Have you thought about how that would work in
Broadly? It probably wouldn't work well with my current approach. This is a problem that companies I've worked at have run into, specifically when I was at Canva, because they were doing generative AI stuff internally with their own training set. It was a lot about how it was actually about avoiding having that big mess of data and having much more constrained RAGs that contained relevant things, because again, we're talking about these extremely limited context windows. Even if it's 10,000, 20,000 tokens, that's not that much, right? So yeah, I don't know if at the current state, and I think this is why I don't think that LLMs will ever be AGI, right? They're never going to be general intelligence, because they are really limited in their ability to look at an arbitrary set of things and sort of reason about it. Because they're going to always just fall to whatever the bias of the thing you're asking them to do is, especially with the instruct models. So yeah, I don't think this model would work well for that. My approach to that would be a more traditional data science approach first, to sort of separate out the data sets as much as possible. And I think that's where a lot of people go wrong when they're using LLMs, is that they think that they can avoid the usual data science approach at the beginning. But like the reality is that it's only going to work if you've got clean, usable, functional data. They can reason well over some things, but it's got to be within the range of their knowledge and their expectations.
Thank you.
No worries.
You said you went agent mad.
I went a bit far.
Did you wind it back?
Yes. It's less agents now. I think at the peak I had like 60 or 70 different agents. Because at a certain point it was diminishing returns, but I was seeing continual improvement. So I'm like, oh yeah, I'll just keep pressing the same dopamine button. Yeah, there is a point and a limit, and I think right now is sort of sitting at about 10 to 15 is a nice sort of range, depending. I can scale it up more. But it's sort of written in, like, my main limitation is actually just how long the LLM takes, really, more than anything. So if I have the main thing I try to do is if I'm seeing, like there's two things I'm tackling. There's how long it takes to come back with a valid response, but also how valid that response is. So I sort of have like a reasoning process I go through. Am I getting consistently valid responses from this thing? Sweet. But is it taking too long? So if it's taking too long, but I'm getting valid responses, there may be room to split it a little bit. If it's neither, then it's probably too large. So yeah, so it's sort of like, it's a very big balancing act. There is a limit.
You talk to somebody, like you talk about the documentation agent.
Yeah.
The other one.
Yeah, I mean, I talked a little bit about, I mentioned some of them. So I have agents whose primary job is to look after auth-n, auth-sed for different, so when I say I have 15 agents, some of those agents have different iterations for different languages. So like there's like an auth-n, auth-sed agent that is sort of like, you know, its prompt might be, you know, you're a security engineer whose expertise is blah or whatever. It's going to be more detailed than that, but just a generic thing, you know, and your focus is in Ruby on Rails authentication and authorization. So there is like there is more generic ones, and then there's more specific ones. But yeah, to not go too deeply into it, essentially most of them center around identifying constructs in the code. Specifically, it's primarily web applications because that's most of what we do. Identifying constructs in those that present risk. That's sort of what the agent's primary tasks are. So some of those, like I said, auth-n, auth-sed. Some of them look for framework-specific things. So there's like a framework expert bot who has access to information about the particular framework that the thing's written in. So that might be, like I said, like Ruby on Rails or I always draw a blank, Django, etc. Pick a framework. It's going to be the expert about that framework, because the common thing I see, if we look at the OWASP top 10, not that I think it's a particularly good set of things, a lot of them just center around misconfiguration, like people foot gunning themselves half the time. That's most web application risks. So having agents that cover off the foot gun angles is important. And then I've also got ones that more specifically look at the actual code itself. And they'll try to reason. So there's like I call it like the expert agent. The goal of the expert agent is to try to understand what the standards and practices of the code base are, because I found it's quite capable of going, oh yeah, no, this thing, you know, deviates from the standard and from the practice. So similar to what you see, I don't know if anyone's ever seen the output from like SemGrep or like a SAST, a static analysis tool. You typically get back these things called taints, right? And a taint is like, I found this regex match, and then I get the sync, which is like how to get down to that taint, like where that goes to. So we actually have a similar sort of process happening with the LLM where it's I found this violation of standards. How does this get to this? And then the other things can come in and provide more context around that. So it gets twisty. Holding a mental model of it has been probably the hardest part, because no one truly understands how these things work. Even with chain of thought, which like OpenAI like ban your account if you try to ask what the chain of thought is now, any more than what they give you. But yeah, having chain of thought is very helpful. So there's a new component in LLMs where you can ask it how it got to the thing it got to. And that's only happened recently. That's helped a lot. And I've actually been able to accelerate a lot in the past like 2-3 weeks having access to chain of thought, because I've been able to like get those niggling things so when I get useless output. Yeah, it's a lot of different things. It was a very long learning process, and I wasn't sure I was ready to invest that much time in it, but apparently I was.
How much?
How much to buy? Or?
No, you said it was $1,000 before.
Oh, now it's like 50, 40 bucks, 30 bucks. But also, I'm not hitting it as hard anymore. I'm not. Part of that was me, not entirely OpenAI's fault, I will say, but Bedrock has been a substantial cost reduction.
I have a two-part question for you.
Yes.
One is, have you named the agents? The second one is, are you attached to one more than the others?
I know one I dislike the most. I don't like any of them, but the one I dislike the most is actually the documentation agent, because everyone writes documentation differently and it struggles with certain formats. I have named some of them, but they're very offensive names in a lot of cases. I'm not going to lie, some of them have been written in frustration. Long term, I intend to name them more formally. As part of the open source release, they'll be named after what they do. But yeah, I actually haven't decided on a name for the project fully yet. So like internally, in the cases I've used, that it was called copacetic because it was supposed to return like an okay, you're good to push your code. But I don't really like that name. So I'm also open to suggestions for names. I don't mind, as long as it's offensive and whatever you think's relevant.
Right, pizza's here, I've got to go.
Oh, perfect. Pizza's here, good name.
Is there much else in the way of competing open source projects like this?
Not open source, so definitely are commercial ones. I've seen some light demos in open source. I think a lot of people got to the point I got to and had a bunch of spaghetti and didn't want to keep going. But I am starting to see this become more and more common. So I don't know if anyone's ever listened to the Absolute AppSec podcast. Really great podcast. The two guys that run that, one of them runs a security consultancy. And he is huge into doing this for his customers now. So there is a commercialness about it already. But yeah, open source wise, I don't think there's anything that's hopefully quite this mature. For me, I kind of wanted to open source it because it was a learning process for me and it's made my life, I wouldn't say it's made it easier yet, but it will. And I hope it makes other people's lives easier. And also, like at the end of the day, I'm just a proxy for other people's things. Like I'm using third-party services, so I'm like, yeah, it doesn't make sense to monetize it. But yeah, it's an open source wise, nothing quite the same yet.
And the $50 per pass, that doesn't include going through.
That's not per pass. That's my monthly bill.
Oh.
Yeah, thank God it's not per pass. Oh, I could buy a SemGrep license if it was per pass.
So you're not having a loop to go through all the dependencies in the poetry.lock file?
No, I've got those. So I parse those out myself now. Previously, I was using LLMs to parse them out because I was just too lazy, but they're all parsed out individually. And I do an enrichment process where I have I use OSV or a local cached version of OSV to pull information about those dependencies separate from the LLM. And then the completed output of that is passed on because it's going to come back. So it also parses vulnerabilities in code, right? So it's going to get, I don't know if anyone's seen a sneak scan in 2024. It's like, 20 bazillion criticals and none of them are relevant. It's going to get all that information and try to reason over it. That's sort of a long-term project, but right now it's returning that information as well.
You started with a challenge and you ended up with success. What was your biggest architectural challenge in the moment?
I think
your whole journey, which was the most
well, having to refactor it thrice was probably so I have a background writing bad stuff. I'm sure that like Tucker and Ryan can attest to some of the terrible things that we had to do in the past. But yeah, I have a tech background. But having been in security, we spent a lot less time. I spent a lot less time writing and developing stuff. I spent a lot more time talking to people about how to develop stuff, to be honest. So it was good to get back into this mentally. But yeah, the biggest challenge was the continuous refactor. Like, especially, 1 week I'd be like, oh, this new feature's out. Great, it completely changes how my workflow is going to work. But I'm like, I need to use it because it's going to get rid of all of this code. And like, my Python was, when I talk about spaghetti, it was one file that was like hundreds of thousands or it was hundreds of thousands of lines long. There was no classes. It wasn't object orientated or anything because I'd been only using Go basically for the last 3-4 years, and I completely forgot how object orientation works because Go's not OO. It's composition based. So yeah, to be honest, the whole thing was a big challenge. But yeah, shifting from OpenAI to Bedrock was actually quite easy. That wasn't hard. Probably just the taking my Python and turning it into something useful was the hardest challenge for me because I'd even forgotten what I'd written like a week ago, as is tradition. Yeah.
If you've named your agents, do they have like departments? Do you have an HR boss?
I've thought about that. They currently live in folders that make sense, but then the files are named like really offensive things. But yeah, no, that'd probably be a logical way to organize it. I want to have like the complaint LLM just as a joke, like an Easter egg where someone can go like, this sucks, take me out of here or something, and it just says it's okay and pats you on the head kind of thing. I needed that a lot. But it was a really interesting adventure, I guess, cutting through the hype of LLMs, because there's a lot of hype when they first dropped. Everyone's like, oh, this is going to change everything. And I found that they're actually not very good. Most of the time is what I discovered. They're not very good. And you treat them like educated children. It's probably the best way I hate anthropomorphizing the things because they're just a statistical model, but I found that if you give them very specific instructions and a very limited sandbox to play in, they'll do much better than if you give them the whole backyard. And if you give them the whole backyard, I don't know who has kids here. I don't personally have kids. I have 2 dogs, though. If I give them the whole backyard, it's a mess, right? Well, imagine if you give kids unfettered access to the candy shop or something. That's what LLMs are like. They're going to go grab shiny stuff and do silly things. So
here's a thought that I've been having, and I'm interested in your opinion on this. I think we need to get way more architectural in where we and how we use LLMs and RAG and agents, and it's the next generation's going to be about the architecture of it, not about prompt engineering.
100%, yeah. I think prompt engineering is a fad. I would argue. I think it was a way to give people more utility out of chat style LLMs. But yeah, to make large language models useful long term, I think it will shift more towards the MLOps space. That's just my thought. Obviously, data scientists are really happy as well. So, either way, but I agree. I think it needs to have a much more standardized architectural approach, and to be honest, to be taken much more seriously, not so optimistically. I think it reminds me a lot of back when DevOps became a thing and everyone's like, oh my God, DevOps is going to change our lives. Everyone's running around and saying, I'm doing DevOps. I think it's the same sort of thing that as it becomes more mature, it'll become more useful. And similar to the .com bubble, I think it might just be getting really hot really early. And then over time it might drop and then it'll boom back up. That's my thoughts. I also would like to say that this does not reflect your unique financial situation, and don't make investments based off my recommendation. Cool. Thank you. There's pizza, right?
Yes. Thank you very much.
Thank you.
For taking all the questions now.
No, it's no worries.
Hello, everyone. My name is Joel Ike. I'm currently a consultant at Green Cloud Consulting, and I dived into the cloud space last year. I'm going to tell you a story of this funny story. So after going into the whole cloud space, I thought to myself, what other way can I actually know the cloud better, or what difficult exam am I actually going to take? And a friend of mine said something like CKA. He mentioned it as a joke and walked away. And I was like, let's do it. Stupid idea. It was 4 to 6 months of agony trying to pass that exam. And when I passed it, I got to talk to my mentor, and he asked me why CKA. And that caught a ball rolling in my head. And I came up with this topic, why CKA? Why would an ordinary cloud engineer or a DevOps engineer need to have an idea of what CKA and what Kubernetes is all about? Why do organizations still prefer to use Kubernetes even when moving back into the cloud? Why do people stick with Kubernetes? And at the end of this presentation, we should be able to understand, first of all, the concept of Kubernetes. We should be able to understand the benefits of Kubernetes, the challenges of Kubernetes, the integration of Kubernetes with AWS, and the final most important question, why Kubernetes? We'll start up with, what is Kubernetes? Now, I'll give you the boring definition, which was given to us by Kubernetes documentation, which is Kubernetes is a portable, extensible, open source, blah, 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 for managing containerized workloads and services, boring, that facilitates both declarative configuration and automation. Pretty easy for a lot of people who are high level to understand, but I'd like to bring things down to a lower level for myself, and this is my best definition. Kubernetes is an open source container orchestration tool that manages your application in the form of containers in an automated and efficient fashion, so you can easily deploy numerous instances of your application. Keywords: container orchestration tool, and our keyword, container, and our keyword, application. Most important, numerous instances. So Kubernetes basically helps you manage your containers better. And what other tool that actually manages your application but your container? And so it just helps you redeploy your containers in numerous instances on the same server or multiple servers, depending on what you want. And it ensures that you can easily manage those containers. Now, when I talk about containers, certain organizations use up to 100,000 containers just for production. And that's the amount of containers we're talking about. And Kubernetes is your tool to manage that. When we talk about the organizations that use Kubernetes, we talk about Google, we talk about Spotify, we talk about Niantic, we talk about New York Times, Asana, China Unicode. These are just a very few. There are thousands of organizations that use Kubernetes, and a lot of them that actually prefer to use it even on the cloud. Now we'll start with the history of Kubernetes. Before we dive into what really Kubernetes is, we'll start with how Kubernetes came to be. And we'll start with the fact that prior to this generation of technology, we had applications that were released with a monolithic architecture. And these applications were they had sections that all made up the application. And each section worked together to form an application. But each section could not do without the application. So outside of the application, the section could not live outside of it. And so we graduated through the formation of containers to have microservices that actually can exist as an external body outside the application and also combine together to form the application, which makes a lot of things easy in production in recent years. And when I talk about containers, I first of all have to say that containers are more or less lightweight softwares that contain the application and their dependencies. And before we talk about containers, we can easily talk about how we transcended from physical servers, which is not right here, down to virtual machines. And virtual environments or virtual machines more or less hosted applications in their own, in isolation. And this isolated hosting more or less took a lot of capacity resources that would be used to host more applications. Containers came to actually solve that challenge and ensure that we could actually host multiple applications on the same server and ensure that resources were highly utilized no matter what. Now, the problem that came with having multiple containers became a problem for developers or for organizations, in the sense that having 100,000 could mean that you have to spend more on overhead for operational expenses or even cost expenses. And so Kubernetes came out to actually solve the problem of multiple containers and try to manage it as one single tool. So you could actually host your application using the Kubernetes platform, and it will help you fully ensure that your load is fully distributed and you can host it on multiple nodes, as much nodes as you want. And you could host millions of instances of the same application depending on what you want to do. It's important to also recognize that Google, some members of the Google team actually created Kubernetes and worked together to make this, to bring this into existence. Now, we'll talk about the components of Kubernetes. The first thing I love to break down, because this was really difficult for me learning when writing CKA, but I love to break it down in the most human possible way. I love to divide this into two. So the Kubernetes cluster, so the Kubernetes is made up of a cluster or multiple clusters. These clusters contain two different types of nodes, which is the master node or the worker node. The master node is this node that has the control plane, and it controls a lot of worker nodes, which are more like the minions or Autobots, if you can say. This Optimus Prime, Autobots, what's leading. And what I would say is the master node it contains the control plane components that ensure that every single activity that happens on your worker node, which hosts your applications, happens effectively, efficiently, and also without any issues. Now, the first control plane of component I would like to talk about is the most important thing, which I'll call the nervous system of the cluster. And I'll say that is the API server. It more or less goes around the entire cluster, looking for information, passing information from different components to each other, to other components, ensuring that the cluster maintains a very, very efficient ecosystem no matter what. The next component I'll talk about is the controller manager, which makes sure that whatever you've actually stated to be done on the nodes, on the pods, like the number of pods, the number of nodes and everything, it's always going to be the same no matter what. It also is very important to know that the controller manager also checks for the health of the pods and the nodes. So in order for the nodes in order to make sure that, because one of the benefits of Kubernetes is that it's highly scalable, automatically scalable. In order for the cluster to automatically replenish failed nodes or failed pods, it has to know about it. And the control plane is one component that uses the API server to actually obtain the information it needs to know about the nodes and the pods, and actually recreate pods and nodes when necessary. The next, it's also important to know that the controller manager it can be grouped into a lot of other managers, which is replication, controller manager, and so on. But we'll move on to the next one, which is the etcd cluster, which is a key value store. And very important to know that everything that happens within a cluster, it would not work if they don't have something to move up to, something like a database actually go up to and be like, hey, what happened? What was right here, or what was moved? What moved? What wasn't there? And so the etcd cluster stands as that dictionary that every other component comes back to check to make sure that everything within the cluster is working perfectly. The next component I'd like to talk about is the kube scheduler. And the scheduler, it's very important to know that the scheduler, every single time you go and tell the cluster, hey, I want to create a new application in a new node, the scheduler takes that information, goes down to the node, finds the perfect nodes to fix the pod in, and actually creates the pod in the node, or creates the application on that node. It's more or less like a filter that makes sure that a node is not overly, the resources in a node are not overly used. And the only way to do that is to make sure that whatever node, whatever application you're building up, is saying that, hey, what is the resource capacity allocated to this application, and what node has the perfect resource capacity to accommodate that application? Now we move on to the worker nodes, or the Autobots, like I said. And there are 3 components. There are just 2 listed there. They omitted the third one. But there are 3 components that makes the worker node work very, very well, which is the kubelet. The kubelet basically is what provisions that application on the worker node. It's what checks the life of that application and gives information back to the API server. It's what makes sure that the application is always running. If it's not running, it feeds information back to the etcd server as well. The API server. The kproxy is also makes sure that the applications can communicate between themselves in a cluster or within the cluster itself. It's more like the foundation of whatever service you're going to build or whatever networking you're going to build on top to make sure that communication goes perfectly within the cluster. The last one that is not there, which I don't know why they omitted, is the container runtime engine. We've been talking about applications a lot, forgetting that these applications cannot run without a container runtime engine. An example is Docker engine. With the Docker, that's what makes the application run. That's what brings the application to life. Now, there are different approaches to actually deploying Kubernetes. The first approach is the iterated approach or iteration approach. And here we just use commands to actually deploy the application. You can use commands to get information from the application. An example is kget-pod. There's a kubectl to get pods, which is, it gives you the 2 different pods that are available that are running in the cluster. It's also, you can use it to deploy, which is krun engine X, which is an Nginx application. Another approach is to use the declarative approach, which is it's more advisable to use because at this point, you have a documentation to always look back to. So in case you want to make changes to the cluster, you can always go back to this documentation to ensure that the changes you want to make are what you want to make. And then we'll now talk about benefits. I've talked so much about what Kubernetes is. The first benefit I'd like to talk about is the reliability. And when I talk about reliability, I talk about the fact that these Kubernetes basically can run on multiple nodes. Your application can run on multiple nodes, on multiple instances of just one application. And that means that at every point that there's failover, there's always application running. And the beauty of Kubernetes is the fact that it's automated, so it will always regenerate a new application to actually take over from the failed one if anything happened, in which you can always troubleshoot and get your problem. Another thing is that you can redistribute workload across the numerous instances of our application that is right there. The next benefit I'd like to talk about is automation. Like I said, Kubernetes is built to highly automate itself in a lot of its uses. To scale up, if you want to scale up automatically, you can always scale up with Kubernetes. The automation is built within the system. And portability. We talked about how containers are lightweight, and if containers are lightweight, then the Kubernetes tool which manages containers is therefore lightweight, which means Kubernetes can be used to host millions of applications on a server, something that wouldn't be done if you're using a virtual environment. Faster development. The beauty of microservices is that we could easily release different upgrades of our application over time. That's number one, which we could also use, say, microservices. The use for microservices also define that we could divide the team working on an application into multiple smaller units to work on smaller units, and it's very fast if people work that way. If we have to wait to build an application, it's going to take years, but because due to microservices and how it works, it's easier to build, to get releases every month or every 2 months or every quarter if you want to. And that's the beauty of Kubernetes, helping to ensure that microservices are alive and can do exactly what you want it to do. Easy cloud migration. Now, Kubernetes is cloud native, which means every application that you deploy on Kubernetes can easily be moved to the cloud without any problem. The code can be transferred to the cloud, and it can be used even as a hybrid environment if you want it to be. Also, security. Now, Kubernetes, like every other major tool, is built with certain security tools to help it make sure that you can easily authenticate to get into it. The use of SSH and the use of SSL keys and everything is built into Kubernetes to ensure that your application is really secure. Finally, it's an open source ecosystem, which means that it is always going to be developed, it's always going to be improved no matter what. Being open source means that outsiders can easily impute into its development as a tool. Now, we can't talk about Kubernetes without also talking about certain pitfalls of Kubernetes. What are those little things that would throw you off when using Kubernetes? It's important to note that organizations have found, or there are solutions out there to actually combat every pitfall listed right here. But the pitfalls here are just to tell you that it's not really an easy tool to use. The first pitfall is complexity. For something that manages up to 100,000 containers, it's definitely going to be a lot of headache to configure and to actually work around. Also, we have to also mention that due to its complexity also, it's easy for you to actually lose sight of little things that could actually impact your application negatively. It's easy to actually have a lot of oversights. Another pitfall is the networking, where the higher the microservices that an organization uses means that more networking and more crazy ass debugging to actually find out why one application is not speaking to the next application. And the next one we'll actually talk about is cluster stability. I remember I mentioned faster development as a benefit to Kubernetes. It could also become a problem to Kubernetes. So with every new release means that you have to take down a pod and bring up another pod. With every new release means that you have to actually do a lot of changes within the system. And it's very easy for the cluster to become highly unstable from little mistakes or little errors being made by developers or being made by the administration team. Then we have security. Security was a benefit, and it's also a pitfall because, like I said, little errors in configurations, little little loops that you leave could actually leave bad actors to come in and actually mess with your system massively. And we talk about logging. Now, Kubernetes allows you to log. You can get logs from Kubernetes, but you cannot analyze logs. So you could have millions of logs from your cluster, but how do you actually know what to do with the logs? How do you know what to find with these logs? It's another problem it's another pitfall for Kubernetes. And finally, scaling. Now, like I said, with Kubernetes you can scale. But the problem is, if your application wasn't built to scale properly, it will fail on Kubernetes, and there's nothing you can do about it. Now we'll move on to Kubernetes on the cloud. A lot of the pitfalls we mentioned before can be solved easily by just using the cloud as either an added resource or just moving it completely down to the cloud. And Kubernetes can be used on Amazon EKS, can be used on Azure, can be used on Google Cloud. But we'll talk about Amazon EKS today. Now, Amazon EKS basically just takes a lot of the hard work that is left on developers with Kubernetes and just takes it and says, hey, we're taking the burden, just deploy your application. The first thing is taking care of the control plane elements, which means Amazon takes control of the EKS of the control plane, which means your patching, your scaling, your even your backups, every single thing that has to do with the motherboard and everything, controlling every single thing that you do is taken care of by Amazon. And that removes a lot of headache from the organization and leaves you with your worker node where you can easily just deploy applications on, and which is a Kubernetes data plane. It's also important to know that this data plane can be managed, and you could actually, there's also a possibility for AWS to also help you take care of the same patching of your own worker node as well, to ensure that your application runs perfectly. Now, it's also important to note that your application on AWS can be provisioned on an EC2 instance or on Fargate, which means if you don't like the server approach to deploying your application, you can always make use of the serverless approach to deploy your application. Finally, and very importantly, EKS is Kubernetes conformant, which means that you don't have to start learning new commands to use the AWS platform. You can always just use whatever you've used on Kubernetes on AWS, and it's easy for you to actually just move your code. You don't have to change your code. You don't have to change anything. Just move it from on-premises down to the AWS platform. Also, you can easily deploy or provision your resources using the console, the CLI, or even Terraform. And this is an example. Another very important note to make is that you can also, the beauty of EKS means that you can use AWS services with it easily without any problem. You can use the S3 bucket, you can use the IAM role, as well as even the AWS SDK. You can use whatever services you can. You can easily intertwine it with your cluster or with your EKS cluster. Now, the real question, why Kubernetes? We get to understand that the more we keep seeing tech getting better, we keep seeing the use of microservices more and more, and which means that more organizations are more likely to switch to using containers to deploy their resources, especially with the fact that they know they can easily release different units of that resources. They can easily reduce the work on their developers to creating large applications and just create mini applications out of those large applications. And so the first thing we can talk about is that EKS basically helps you manage the thousands or hundreds of thousands of applications of microservices you will have. It gives you flexibility and control in the sense that you can always tell yourself, like, if you want to use a hybrid situation where you don't want to use the cloud completely, due to the fact that EKS can easily Kubernetes can easily be used as a hybrid environment. You can easily gives you that flexibility to do what you want to do and control also. Compliance and security, which means that if you have governance issues with a lot of the applications or a lot of services that AWS has to offer, you can always create your own applications on Kubernetes and actually redeploy them to do what you want to do. Cost management as well, which means if you look at the cost and say to yourself that AWS services, some AWS services are not really a little bit too pricey, you can also do that on your EKS, on your Kubernetes cluster. And legacy integration, which is the most important. you can easily integrate with AWS or any other cloud service, no matter what. What have we learned today? We've learned about the concept of Kubernetes. We've learned about AWS EKS, and we've learned why organizations would use Kubernetes. Thank you, everyone.
Do we have any questions?
Do you know any workload that might be more useful to use a VM instead of container and all those Kubernetes other things?
Yes, there are situations where VMs will be more useful than containers, which takes us back to the fact that if you have if you're a startup company and you intend to just create one, like have a single application that runs on its own, it will be more advisable to just use a VM. There's no need actually getting a container to do whatever job you want to do. Thank you.
To kind of go in the other direction, when will you use serverless versus Kubernetes, or I guess containers, but maybe more so Kubernetes? Why would you choose Kubernetes over serverless?
Kubernetes over serverless?
Yeah.
All right.
Like Lambda, for example.
Okay. So if your microservice is not going to run because I know Lambda doesn't run continuously. If your microservice is going to actually run for quite a while, like for a really long time, it wouldn't be advisable to use Lambda. It would be advisable to just use the Kubernetes platform and run it as a container instead. But let's say if your application is short-lived, or whatever web service you want to build is short-lived, yeah, run it on Lambda. It actually makes a lot of sense there.
How's the scaling controlled for like web services?
Scaling. So this is where Kubernetes, or this is also one of the few problems that I've had with Kubernetes. You have to build whatever you have to, like you have to build an automated system to scale it automatically. If not, you can easily just leverage using the file to actually say, hey, I want to always put 3 instances of this particular application out there. But you can't automatically say, let's scale it according to its usage. So if you have to build an application, which is where I talked about integrating with AWS services, where I forgot to mention that the EKS can also run with an auto-scaling group. It's one of the beauty of AWS. So you have the ability to automatically scale no matter what scale to what you want it to scale to. If you want it to scale to a particular memory, if once it gets to a particular memory, it scales up or scales down, you can set those settings with the EKS cluster, with the Amazon EKS.
Something starts to go wrong. How visible is the performance of the whole setup? Like, it just seems like it's more out of your control than if you had it in a classic sort of structure.
Yes. So a lot of I believe when they created Kubernetes, it was more or less to be like the Google team created it as a way to just host multiple stuff that they've built in containers to actually work with what they've worked with. Now, it depends on the organization and what they want to do with it and how they want to actually build with it. If they intend to use Kubernetes, then they should have a team that will actually develop applications that will do a lot of the automation automatically for them, or do a lot more sequencing or whatever thing they want to do with it easily.
This is like at the application layer, and then all of these instances are coming back to a database.
Yes,
Is there a Kubernetes equivalent?
So you can easily, so that's the thing, you can easily deploy the database on the Kubernetes cluster, depending on what you want to do. So one of the few, I forgot to actually put a diagram of what it could look like. So you could have your application running all in the same nodes, different nodes. So a node could host your application, and a node could host your database, and a node could host maybe your backend or whatever, or your front-end application of what you want to do. So the whole idea is that you are the one deploying applications. The Kubernetes cluster is just there to help manage those applications to make sure that it is running perfectly no matter what.
Database instances in your...
Yes, you can have multiple database instances.
All pointing to the same physical store somehow.
Yes, all point to the same physical store if you want to. Yes, that's true. Thank you.
Can I get a round of applause for Joel presenting?
Thank you.
Before we all leave, thanks to our supporters that make this event possible and get you pizza. Ideal event was an AWS here in the building. Then we have a YouTube channel. Feel free to scan the code. You will find recording of the talks from today and past events, so you don't miss out. And then the next user group, if I speak slowly, it's going to be in January, so you can all go off and enjoy your holidays. We have a small sneak peek for next year event. I'm going to hand you over to Alan, who's walking here like a ninja.
Oh, I don't like to interrupt. Yes, I do. I always like to interrupt. So I can announce today, finally, after about 6 months' worth of organisation, in August next year, we're going to be arranging the first Brisbane Community Day, which will be arranged between Melbourne user groups, Sydney user groups, Brisbane user groups. We're all getting together to put on a Community Day here in Brisbane. So watch out for that announcement in the new year. It'll be around about August 2025. Venue to be arranged so far, but watch out for that announcement in the new year.
You know, when you see an announcement, oh, there's a community day in this country, in this other country, all around the world, we're going to get our own one.
We've not had one in Australia in person since 2019.
What is a community day?
Okay, good question. Thank you. Just in case people hadn't heard what a community day is. A community day is very much like a mini summit, but ultimately it's put on by the community for the community. So, we've not got AWS with their, Gen AI influence and commercial influence. It's ultimately run by the community on topics the community wants to hear, by volunteers, for the community. So that's what a community day is.
More sneak peek?
Huh?
More sneak peek?
No more sneak peek.
You never know. We don't have the date for January, but it will be announced eventually. And then we have a feedback form. So if you like to scan the QR code, which hopefully works, you can let us know what you think about the event today. You can give feedback on the talk, on the venue, or anything you want to tell us. Feel free. Does it work?
It works.
Yes.
There's been a few events this year where that's not worked, or it's been the month before.
Because we like to keep you on your toes. So does it work? Does it not work? You got to stay until the end of the day.
On a pre-filled out one.
All fives, yeah?
Yeah.
Yeah, and I think that's all for tonight. So thanks everyone for coming. If there's still pizza outside, feel free to take some with you.
Thank you, Clark.
Thank you, team. Thank you, speakers. Please come back.